This can no longer be an excuse. First, the James Webb Telescope has found the first real evidence that would shake cosmology. We can't still cling to old theories and shout that they are still valid. The start of the James Webb mission has dawned a new truth for scientists. They now have to admit that they have been wrong for decades and they have been selling us pure assumption as unassailable truths. What else can we say? The James Webb Telescope gives us so much evidence that the Big Bang and all the standard model of cosmology is wrong, and some could even say it's almost like astronomers, astrophysicists, cosmologists have been living without reality. But they still say we were formed 13.8 billion years ago from a Big Bang. So how can the James Webb Telescope present us with pictures of the galaxies it took pictures of that must have been many billions of years old, like our Milky Way, which is about 13.6 billion years old? Sears 2112 is almost an exact twin. Just 2 billion years after the Big Bang, Sears 2011-2 was a beautiful barred spiral galaxy. The galaxy Aztec 71 only existed 900 million years after the Big Bang, and wouldn't have been seen by any telescope other than James Webb. The lurid galaxy Jades GS-Z13, which existed as a complete and luminous galaxy just 320 million years after the formation of the universe. It is therefore, at present, the oldest confirmed galaxy since observation began. In these galaxies, we're seeing them so far developed that, under the previous cosmological assumption, they should be several billion years old. Billions mind. You. However, these galaxies only existed just a few 100 million years after the supposed Big Bang. We can never, in the way galaxies are so complex, consider these galaxies baby galaxies far and wide. Nothing remotely like newly born galaxies is in sight. What all researchers see are giant, large, luminous galaxies that are full of stars. Science continues to lie. Astronomers face a huge challenge trying to figure out what these galaxies, so big and so early, are up to. They ask the question, but how could such massive galaxies evolve over such a small amount of time when they should take the full amount of time necessary for such an evolution? Nobody in the scientific community is anywhere near challenging the Big Bang. Instead, scientists remain convinced that this starting point happened 13.8 billion years ago. Stars and galaxies grew faster, they say. However, few scientists will talk about what they think the universe may be older than. But if we go back into the history of the science, many of the theories were solely the product of observational and assumptions. Other observations have since called into question even the theory of expansion, which in the end also proved the Big Bang. So, just to name a few, let's take a look at some of the crazy ideas scientists have now come up with to save their beloved Big Bang. So, what is all this bursty star formation? It's become impossible to deny anymore that the discoveries of the James Webb Space Telescope are upending our assumptions of what protogalaxies were like back then. The JWST is now able to see thousands of so-called unusual bright galaxies, whose luminosity and size fly in the face of astrophysics. The galaxies in question are similar in luminosity to our own Milky Way, and they formed at a time when the universe was supposedly just starting out on the path to its first protogalaxies, or protoclusters of stars. To some scientists, however, the answer may lie in a phenomenon called bursty star formation. In sharp contrast with star formation in today's universe, these early stars may have formed in sudden intense bursts, interrupted by longer periods of quiescence. Supercomputer simulations that reproduce the early universe's dynamics supposedly prove that the cosmos was awash with star formation at extreme rates, which in turn supports the theory. But somehow they also formed hundreds, or probably thousands, or even millions of galaxies at breakneck speed. JWST discoveries challenged standard model of the cosmology, which says that galaxies grow slowly and hierarchically. Now, with the new simulation results coming in, we know that a galactic system doesn't have to be massive in order to be bright itself. These galaxies would have had to periodically hit brief but intense bursts of light if star formation occurred in massive bursts. That should help to explain why we can see several very bright galaxies that were formed when the universe was less than 400 million years old. Galaxy formation has been controversial for some time. An uncertainty in the astronomy is fascinating the time when the first galaxies were first formed. But for us to know the answer to this question would be of central importance to the understanding of how the universe and everything within it came to be. Cosmologists have traditionally assumed that the first star clusters, these are forebears of modern galaxies, grew gradually over the first few 100 million years after the Big Bang. The Big Bang itself is dated to around 13.8 billion years. Ago and the Dark Ages, that early phase of the universe between the Big Bang and formation of the first stars, are still around too. These first star clusters were to be the building blocks of the later galaxies. The rate of these processes were slow and steady, according to cosmologists, and the first proto-galaxies had formed between 200 and 400 million years after the Big Bang. Until now, these numbers were based on what are known as models of stellar evolution, calculated using the rules of gas and dust motion in the early universe. Now, though, the latest observations by the JWST tell a different story. Even James Webb's most dramatic discoveries are not a single galaxy anywhere near these models of stellar evolution. The JWST has the unrivaled ability to peer deep into the universe and has captured galaxies so close to the Big Bang that no previous models match. Although the habitable galaxies were specified to have originally existed 300 to 900 million years after the Big Bang, if we add to this the time these galaxies evolved through, then they would have had to have originally been formed before the Big Bang. That would mean that the theory of the Big Bang is wrong, partially at least. So, how did researchers come up with the idea that 13.8 billion years ago, the Big Bang happened? Several scientific observations form thesis of the estimate of about 13.8 billions of years for the age of the universe. In 1929, astronomers Edwin Hubble discovers that distant galaxies were speeding away from the Earth, and the faster they moved, the farther away they were. The combination of these two led to this being called Hubble's law, and taught us that the universe is expanding. Theoretically, it would be able to reverse this expansion so to get to a time when the universe was very small, the presumed time of the Big Bang. Further evidence of the discovery of the cosmic microwave background radiation, CMB, discovered in 1965 by Arno Penzias and Robert Wilson is interpreted. The CMB is really a faint glow that permeates all of the universe. Most astronomers believe that it is the result of the reionization of the universe, the process by which the universe became transparent to light, and they assume that the CMB is something like the afterglow of the Big Bang. Then elements of directional movement in the CMB have until now seemed to fit with ideas of a space expansion following an initial event. Back calculations of the CMB are also used in calculations of the age of the universe. The basis of this is the standard model of cosmology, which fits that picture based on Einstein's general theory of relativity, assuming a universe that is dark matter and dark energy dominated. When calculating the age, dark energy, which opposes gravity and speeds up the expansion of the universe, was also considered. Finally, the distances and speeds of very old galaxies and stars were also measured. Final stretch in the calculations. But we have now crossed the threshold of what previously models were no longer good for, and of course it's true that the CMB can also be interpreted in very different ways. Neither has the expansion of the universe been proved. However, researchers have found that the universe isn't expanding evenly everywhere. A second use of dark matter and dark energy had to be used in order to explain these effects. But here, too, we come to a crucial catch. We have yet to prove that dark matter exists, or that dark energy exists. But when we look at the facts, there's no excuse for this. A few concocted theories whose interpretations in turn depend on observations, all in turn dependent on various other concocted theories that are to our world something like our understanding of cosmology, except they are based on incredulous and perhaps even outright false observations. All of which, it should be noted, never really made sense anyway. Now, dark matter was invented by scientists, and now there is undeniable evidence that everything is not as it should be. Science just continues trying to fit the shiny, new discoveries into previous standard models. We could be losing an urgently needed new beginning in this way, our science. What we need are facts, not explanation. The Big Bang Theory, so beloved by most scientists, is clinging doggedly to it, because of a dozen's observations and a dozen's models, even though it doesn't seem to stand the test of statistical rigor. And there are facts out here in these pictures, and scientists don't want to admit that they were wrong. For almost 100 years, their previous models have been convenient and coherent answers to explain a lot of things about the universe. They sell the theories to us as truths, and they were, and are, doing it. No one ever really doubted that scientists really knew, for sure, about the Big Bang. Now they didn't know, and everything was coming out. Most researchers will not admit, but there is another way. And there are new ways of going about things, and we can assume an emergence of a science of openness and the like will happen, according to new theory proposed by Indian-Canadian physicist Rendra Gupta from the University of Ottawa in Canada. Gupta's theory draws on two assumptions that it combines: the current assumption of an expanding universe and his hypothesis of light fatigue, and concludes that perhaps the Big Bang occurred 26.7 billion years ago, twice as old as people previously believed. This idea of light fatigue was invented by the Swiss astronomer Fritz Zwicky, who stated that light simply gets tired in so long distances that its effect becomes slower, the frequency decreasing, and the wavelength getting longer. But, if it is true, then all of our calculations about our age of the universe, age of early galaxies, would be off. If tired light is considered, the theory of an expanding universe would be completely different. The variable constants of nature theory, which states that in the early universe, physical laws could have been rather different to what they are today. If so, the fine structure constant or the gravitational constant, or more fundamental physical constants for that matter, should have varied over time or may have had a value that was different in different areas of the universe. Finally, the Mon theory now also tells us that the dynamics within galaxies, so largely influenced by dark matter, can equally be explained without any dark matter.